Hi, everybody. I have no idea what Stella said about me, but I hope it was really nice. Huge thank you for inviting me here and having me speak. I love Colombia so far. It's really an amazing country. So yeah, I'm going to start off by talking a little bit about site availability. So there's a scenario. Your phone, it rings, the middle of the night, the website is down. Every person on your engineering team is on vacation. It's just you. Do you feel like you know what to do or where to start? My hope is basically that by the end of this talk, if you don't feel like you know what to do, you'll feel a little more confident in finding ways to get more comfortable. For the rest of you, you'll get a refresher and maybe get some ideas for people on your team who are maybe not as confident. One of the biggest challenges that I found with site availability is that it catches you totally off guard. Basically, every day we practice writing code, we refactor, but a site outage can happen anytime for a bunch of random reasons. And this randomness can be pretty scary. And I'm going to start off by kind of telling you my scary story. In July of 2015, I was working as a Ruby developer at a website called Indiegogo. It's a crowdfunding website, so people can basically go and fund things that matter to them. So we've had a ton of successful campaigns. There's an Australian beekeeping campaign that raised like $12 million. The movie Super Troopers 2 was funded on Indiegogo. And so in July of 2015, this big news breaks, international news. Greece is the first developed country to fail to make their IMF loan payment. And through this like weird course of events, this actually brings down the Indiegogo website. And it's in the middle of the night in California, we're all sleeping, and Europe is waking up and they hear this like amazing story on TV where this British guy has this great idea where he's just gonna end the Greek financial crisis. So he decides he's going to help the Greek people by launching a 1.6 billion euro campaign to just bail out the whole country, get them back on their feet. Everybody throws in 3 euros. Just you throw in 3 euros, you throw in 3 euros, they're fine, they bail out Greece, everything's fine. So people start coming to the Indiegogo website. It's like little bits of amounts, like 3 euros here, 5 euros here. They're contributing and contributing, and eventually our site just collapses. And it doesn't come back online until we put up a static page that just takes the load off of our servers. And so for me, this is unlike anything I do. I work on a payments team. I write Ruby. I don't do any of this stuff. And so I was really unprepared and I was really afraid. And I'm thinking afterwards, I'm like, how could I have been more prepared, right? And so that's where load testing came in. It's this cool programmatic way where you simulate a bunch of users making requests to your website. So it's like a kind of a low stress simulator for really high stress situations. And you can play around, you can build your confidence, and you can come up with your own site availability playbook, your own ideas about what to do during outages. And then you also, if you make performance benefits, you can potentially benchmark and see how those performance benefits help you. And really the downside of all this was that there's a lot of high-level instruction about how to just do a load test. And then there's a lot of really technical instruction about site performance, but there wasn't a lot of stuff to bridge the gap. So this is kind of my result of trial, error, and Googling. And so through the course of this talk, I'd like to share a bit about how you can start getting a load test going, how you can turn up the volume to sort of simulate the load on your website, and then a couple of tools to just explore the results. So how do we get started? So we'll kick off by preparing our load testing tool. And I'm going to talk about Apache Bench because it's pre-installed on Linux boxes, most Linux machines, and it's a really simple tool to get started with. And so this command that you see up here is AB for Apache Bench, and it's basically all you need to kick off a load test. We'll break down the command a little bit more. We'll want to choose an endpoint to send all of this simulated traffic to. So a simple static page that doesn't make any calls to the database is a really good place to start just to get a baseline. And then when you're really confident that your load test is configured correctly, then you'll want to choose a page that will handle all of your traffic. So for us, it wasn't actually our home page. It was a campaign page. But for you, it could be very different. And you can actually start off by testing localhost in this command. But that's really just to like play around, because if you think about the load test, it's actually running on your computer, and so it will consume resources from your website, so it'll eventually interfere with your results. And on the flip side, running a load test against a production website can impact your user experience or even take down your site. So do not do this to your production system unless you specifically are trying to stress test your system. You don't want to do something that's hosting external traffic. And there's like at least one person thinking this, so technically, whatever, it's fine. So in that same Apache bench command, you'll want to configure how much traffic that you want to use to simulate your test. And so you'll need to provide the number of requests. So that's the -C flag for concurrency. So those are concurrent requests. And the absolute total number of requests that will go over the entire course of the test, and that's the -N flag. And so here, this is like super basic. Start with one concurrency, and just enough requests to get the system like warmed up. So this is one request 1,000 times. And you want to run it for a few minutes because your system does sort of warm up in this process. And when I talk about requests, what does it mean? It doesn't actually usually mean a single visitor to your website. Depending on the number of assets that you're loading or asynchronous client requests, it can really vary. So a single unique visitor can make a ton of requests, but if there's caching, browser caching of assets, a return visitor might actually make fewer requests. And then a final thing to really keep in mind is that Apache Bench and these kind of server-side benchmarking tools are not going to render your HTML or execute your JavaScript. So these like latency times that you see are really just like part of the user experience. They're not going to actually be like going in and clicking around. So let's look at this output that comes out when you run this Apache Bench command. So this is the kind of snapshot of the full results. And when we zoom in, we'll see that Apache Bench is showing us the percentage of requests that are served within a certain amount of time. And when you look at these results, you want to make sure that like the results that you're getting here kind of match up with what you would expect in real life. Because load testing is kind of a black box. You just sort of kick it off and it just does some work, but you aren't actually looking at the internals. So if you just plug in some random numbers and you don't really understand your system, you can get these like really great results and you're like, yeah, my site's really good, but it's not actually true. And you want to make sure so you have a hypothesis about like, how do I really expect this to behave when there's no like heavy load? And the best way to do it is to really just estimate on your production system like how long it's going to take to return a request. And it'll give you a ballpark. So for example, this line that says like the 99th percentile, that's basically saying the 99th percentile of 1,000 requests happened in less than 693 milliseconds. So if you have a graph of that 99% line on your production machine, and it's like around 650, you're good. But if your load test is saying you've got 100 milliseconds, no. Like that's really good results, but it's probably a problem with your load testing setup. And like a really common issue that would show like these amazing results is testing an error page, especially if you're using a staging server. Because like if you need basic auth to authenticate your requests, you'll need to actually put that in your Apache Bench command. You use that with the -A flag. Otherwise, you're basically testing how fast you return a 400. And another common issue is actually hitting a 500 or maybe a redirect, because Apache Bench isn't going to follow that redirect, and it'll just log it and they'll be like, oh, it's cool, I got this. Non-200 requests, but it's not actually what you want to test. And the easiest way that you can tell is there's actually an output in Apache Bench. It'll show non-200 or non-2XX responses. And if it's already over 0 and you haven't actually started load testing really heavily, you're probably running into one of these issues. And so if you tail your server logs while your tests are running, it'll be just like if people are visiting your site, and you should be able to see that there are no errors. And another very weird thing is that Apache Bench has something called failed requests, which are not errors specifically. So it actually matches on content length. So if you have these dynamic content lengths that are coming back, Apache Bench will log them as sort of as these failed requests, but they're not the same as errors. So you can see it in the output, and just like check in your logs, make sure that there are no non-2xx requests. And then in later versions of Apache Bench, there's actually a flag where it'll allow you to accept a variable document length. One second. Just going to do this. It's going to take forever. So once you're feeling pretty confident, your low-key, low concurrency error, like test is not having a lot of errors, you can start like turning up the volume so that you really start to load test your machines. And you can start to see how your application itself is impacted by this load. And a really good way to understand how your app is impacted by the load is to explore how queuing affects the user experience. So as you increase the load on your website, the average response time for your users will start to increase. And there's something called Little's Law, which is like a fundamental law of queuing theory. And this is sort of opaque, and it doesn't really make any sense. But if you think about it with a real-world example, it's actually really intuitive. So you have a grocery store. You've got one cashier just checking people out. And the number of people who are waiting in line to check out, it's basically going to be the rate that they show up and how long this person takes to check them out. And so if you have a new cashier who comes on duty, they're brand new, they have no idea what they're doing, and they're really slow, you're gonna notice that that line's gonna get longer and longer and longer. And basically, so if people keep getting in line at the same rate, they're gonna be waiting a really long time. And that's kind of what happens with the websites. And you can adjust this equation around so that you can understand why you would see increasing response times. It's basically, if your server is taking 500 milliseconds to process your request, and that number is going to stay steady because you haven't made any performance improvements, your total response time is going to go up if you keep adding more requests to your system. And our websites, our simple websites especially, act just like a giant queue that you're sending people through. So we'll walk through a web stack that consists of a few things: proxy server, application server, and a database. The proxy server is what's sitting behind your firewall, and it's communicating back and forth between your client, your users, and your web server. This is like HA proxy or Nginx. And your application server, it deals with all these requests that need processing, makes calls to your database. In our scenario, we'll just talk about a single-threaded server like Unicorn. And Unicorn has this sort of master process, has a configurable number of child processes or workers that do all of this work. So even though you have a single server on a single machine, it can handle multiple requests at one time. And so this is like having multiple cashiers at your grocery store to check people out. And other web servers like Puma use multiple threads instead of multiple processes, but it's a similar idea. And in this simple example, we only have one database. All these cashiers at the grocery store are just making requests to this single repository of information. And so the proxy server, your application server, your database, they can all live on the same machine, but they'll all be consuming the same resources. Or they can be on different machines, which they typically are, and they'll have their own sets of resources. Just an example, your web stack will probably look a little different. And so as you add more and more requests into this queue, Little's Law is going to show us that your average response time is going to increase. So you keep adding more and more requests to the system, but if you don't add any more cashiers to help check people out, the line is going to get longer and longer and longer, and your users will eventually experience a timeout. And your proxy server basically allows somebody to wait for a certain length of time, and then it's just going to say, sorry, I can't help you. And one of these kind of weird counterintuitive things is as you're increasing the load on your system, you might think, oh, well, I'll just let the application server underneath the proxy server queue up more requests, right? And that way they won't time out at the proxy server level. But under extreme load, these requests can remain queued up even after the proxy server has said, no more. And so your application server is actually still going to keep churning on those requests even though your user is long gone. So it also goes against kind of a recommendation of queuing theory itself, which is a single queue for multiple workers is more efficient when your job times are sort of inconsistent. So if you think about this in practice, you have 2 available workers, and they're executing jobs, and one is doing this huge processing of this huge file, and the other one's just processing a little tiny file. If you just sort of arbitrarily queue up a request behind this like giant job, the short request is just going to be unnecessarily waiting when this other worker could have handled it. And the other thing that like you may be tempted to do is just increase the timeout threshold. So people are waiting longer and longer and they don't get an error. But that's not really the same, because if a user is waiting and your website never loads, that's going to be worse than just telling them, sorry, the site is down, go away, because they're just going to keep refreshing. And it's not just your application that can be impacted by this load, right? Your operating system is also going to see effects. And so specifically, these configurations might already be in place on your production machines, but you might need to tweak them, especially on a staging server machine or your local host machine when you start off. So the proxy server itself has to keep track of everybody who's coming in, and it does that by keeping track of people's IP address and the port number that they make the request on. And each of these is going to use up a Linux file handle. And suddenly you might start seeing this error come through where it's like too many open files, too many open files, too many open files. And you want to make sure that your operating system itself isn't arbitrarily capping that number. And a lot of times it'll be configured to 1024. And if your proxy server is using one handle for an incoming and an outgoing request, you could actually hit that limit pretty quickly. And so you can actually see what those limits are on your system by using ulimit. And there's a rule of thumb that you can use to calculate that number. It's like in the 2.6 kernel documentation. And it's basically saying a file handle is 1K of memory. Don't allocate more than 10% of your memory to files by default. And so you get kind of like 100 file descriptors for every megabyte of RAM. And so the numbers that I'm going to give here are just sort of like estimates. So you'll want to like tweak them for your machine, but it might be a good place to start if you're having issues. So you'll want to adjust it at the system level, at the high level. You can make that change in the syscontrol. And then you also want to make sure you're adjusting the user limits, because that's what your proxy server is actually going to have to respect, not the system limit. And there's going to be a soft limit, and there's going to be a hard limit. And the soft limit, both of these should be lower than your system limit, because the system limit's like the big umbrella, and this is sort of what's underneath. And the soft limit is what you'll get by default. Your proxy server will get the soft limit, but the proxy server can configure itself to go up to the hard limit. So, save, close the file, reload your changes, and you might find some good results. And finally, if your proxy server itself has a configuration that's limiting it, you should make sure you adjust it as well. And another issue at the operating system level can be TCP/IP port exhaustion. There are just a finite number of ports that are available on your machine, and only a subset of those ports are even available to your application. So these are called ephemeral ports. They're used to handle web requests, and once the process is complete, they're recycled back into the system and somebody else can use them again. And you can kind of tweak 2 settings to increase that number that you have available. One is to decrease time wait, and that way it gets recycled back in more quickly. Basically, the wait is to make sure that there's no stray packets that are leaking from that prior request when it gets recycled back in. But in the load testing scenario, it might not be. It's not really an issue. And second, you can just increase the range altogether, and that'll be on an operating system basis. It's different for all of them. And you should also just make sure you run your load test, you click off, you click it, it runs, just like, wait a minute, just breathe, let it breathe, because these ports are gonna have to be recycled back in. And if you just keep like running it, stopping it, running it, your ports might not be available. And the Unicorn documentation is actually pretty good for having some of these OS tuning suggestions. But at the end of the day, like, your application is this special snowflake. It's very unique. And you have to think about how your application behaves in the wild and how that might impact your performance, especially because this is kind of a sterile test environment. It's fake. And so one example is how your user actions can bust the cache, especially with database queries. If your endpoint that you're load testing right now returns like user comments from a database, for example, you have to think about like, oh, how many rows and like what's the complexity of this query? And if there are no comments seeded on your staging machine already, it's like empty, it's not actually testing what a big user with lots of comments would actually look like. And even more importantly is once you make that first request, it might be cached. And so under real live load test scenarios, people are just going to be commenting, and that cache is going to be busted constantly. So you can actually run scripts alongside your load testing that'll do things like bust the cache, create comments, and that'll help simulate some of these like real world scenarios. And another thing is blocking external requests. If you've got really heavy load and you're calling out to a payment processor and you're waiting on that response, you're just adding to the length of time that these workers are spending with each request, and that will contribute to some of the painful user experience. So at this point, feel good, you understand how your website works basically, and some of the logs that you need to look at to kind of understand where the problems are. And you should be confident that this is a reasonable load test. So you can start looking and using like just simple tools to understand like where the bottlenecks are that you're seeing when you're running these load tests. And a really great place to start is to actually look at the machine itself that's hosting the web servers. So as you increase load, you can run top at the same time to view what percentage CPU and memory are being consumed. And one thing specifically to keep in mind with this that you probably already know is that when you see those percentages, that's a single CPU core. So on your multi-core systems, like you would actually expect that the percentage would be greater than 100. And there's also a really nice alternative to top called HTOP. And it might not be installed on your system, but it has like a really cool visual representation of the CPU consumption. And if you think about the proxy server, the application server, the database, these are all a zero-sum game if they're living on the same machine. And even within those, like with Unicorn, there's just a single master process that runs, and you can configure an arbitrary number of processes to handle these workers. And it's great because you have more workers, and that's awesome. Like, bring me all of these requests, but they're all going to use resources. So you don't want to make sure there are so many workers that you've spun up on the same machine that it's out of physical memory and it's hitting swap space and it's just grinding and moving really slowly. And you can actually look, it's pretty consistent with Unicorn. If you don't have a memory leak, you can see about how much each of these child processes should take up with memory consumption, and you can make sure that you're not taking up too much of your resources. And the other thing is, especially with load testing, because you might be running it all in the same system, everything is going to limit the amount of resources that your application can consume. So if you have your database running locally, you might run out of CPU way before you ever bring down your database. And in real life, when site availability is compromised, you might find that it's actually really easy to spin up more Unicorn workers, but that they're all waiting on your database, and that's locked up. And so it can be really important to see how your database behaves under load. In Rails, it's super easy. You point it to an external database if you have a database server handy, and you can actually test that locally. Just configure your database.yaml. But really, as I said before, do not use your production database because you can bring down your website. Make sure it's not hosting users. And so in the end, like after you've run all of these things, you can also use traditional tools like application performance monitoring on the system that you're running the load testing on, and use things like transaction tracing to see what your slowest requests are. New Relic and Skylight are pretty common third-party tools And ideally, you would use the one that you use in production so that you can have practice using those in real life. Rack Mini Profiler is also a really cool gem. Just make sure that if you're running it on a staging machine, you switch the environment, because otherwise it's not going to actually capture anything. And there are a couple of tools you can use to see how your database is performing. This is actually disabled by default, but if you turn on the slow query log in MySQL, you can see this cool log of just all of these really slow queries. You configure the amount of time, like 0 to 10 seconds, and it'll actually log all of these long-running queries. And another thing that might not show up there is that you're calling a query just way too often. And it's not expensive under normal scenarios, but if it's one of those queries where the cache is just constantly being busted, a query that's not that expensive can balloon when you have a ton of load on your database. And show process list is a cool way to be able to see those frequent queries. And finally, Apache Bench is not always the best tool. Some people don't really like it. There are some other ones. There's Siege, which has you can actually create a configuration file to hit a bunch of endpoints at once. There's a wrapper called Bombard around it, which allows you to sort of programmatically ramp up the load. Bees with Machine Guns is my favorite named tool. It was actually created by the news application team at the Chicago Tribune. And you basically can spin up these tiny Amazon EC2 instances to load test your application. And then Flood.io is a paid service, but they maintain Ruby JMeter, which is a Ruby DSL for writing these test plans in JMeter, which is just another load testing tool. And so your app is probably going to look a little different from what I've talked about today. And it's really hard with these performance scenarios to really have a one-size-fits-all, this is probably what's wrong with your app. But the cool thing about load testing is this kind of way to play around. It's a framework of curiosity. And it can give you the tools to shed light in these really dark places. Thanks, everybody. I'll tweet out a link to my slides if you're interested in taking a look. I'm on Twitter at PracticeCactus. Yeah, thanks so much.